while loop, and we're going to go to different hands-on examples. And the very first one we're going to do is going to be the factor of numbers. Find the factors of numbers. It tends to we may tend to ask you certain things like, can you find the factors of a given number using Python, and how can you make that possible? So we're going to make use of the while loop, and we're going to see how we can make that possible. So I will share my screen soon. So this very good. I believe you can see my screen. So this is what we did in the last class. Play with while loops and see what we did, and went perfectly well. People that attended definitely understood what we're doing. And tonight we're going to continue. Let me connect the kernel and let's get started. So get a new cell. And the very first thing we want to do is definitely to find the factors of a given number. Maybe you want to find, I don't know, maybe in mathematics that you back then in primary and secondary school, going up to the tertiary institution. How can we get the factors of a particular kind of number if you are being told to, for example, say take the factors of 48? How can you make that possible in Python? So we're actually going to, very first thing we're going to do is want to make it practical for the user to put it by the number by themselves. So we're going to define a variable. We're going to define a variable and can name it number. So number is equals to, definitely is going to be an integer. So you're going to pass it an integer, and that input is going to pass an input. And by the time you pass an input, you can decide to just print a statement and say, please enter a number. Okay, you enter a number, any number you want to. Definitely you can decide to just give space and let it look more wonderful when you try to print it out. So now I want to give a particular factor of a number, different factors of a number. So we're going to define a particular variable. I remember when we did in the last class, we're always defining variables when we want to do something like this, so that we can use that variable as a reference. The main variable I'm talking about, apart from the one that the user is going to use. So we're going to give a variable name, and we're going to define that variable. We're going to give it a value. And let's say, for example, let's use 2 for now. By the time we use 2, we're just trying to say, if the number is divisible by this particular number, then that particular one is a factor is going to be what? Is going to what? Print each of them one after the other. Don't worry, I'm going to explain. By the time you see the output, you definitely understand what we're actually doing. So we're going to define a variable. We can decide to claim it as I equals to 2, and now say that while that particular number, why are we using I is equals to 2? Because we don't want it to exceed, like maybe we don't want it to pass 2, we don't want it to start something like 1, minus 0, minus 1, minus 2. We just want it to end at 2 at some point. So that's why we're using I is equals to 2. So while I, which I already defined, is what is less than. While I is what is less than.
Sorry, please, I can't hear you clearly. I don't know. I was trying to type. Maybe it's from my end. I don't know.
Please confirm that you can hear me clearly.
I think it's from network. It's not just from your end.
Well, can you hear me now?
Yes.
You can hear you, but if you can.
I think it's network. It's not just one person.
Are you serious? So let me try and see. Okay. Can you hear me now, guys?
We can hear you, but the voice keeps going up and down.
Okay. Sorry about that.
I hope you are using your microphone or something, or a headset or something.
Yes, I'm using a headset right now.
Okay. We are fine. We are hearing you.
Okay. So let me continue. Okay, so what we're going to do right now is while I is less than that particular number, why I, which is defined as 2, is less than a number, is less than the number in which a user is going to use this. This while loop will definitely continue running. Remember when I said that the while loop always works when a particular condition is true or false. So if it is true, the while loop will definitely run, but if it is false, it will definitely stop. So while I, which is 2, is less than the number which we are going to use, the number which the user is going to bring in, is less than that particular number, it means it's going to run. Now, when you do that, how can we now find the factors of this particular number you want to get to find the factors of it? So is number divisible by this I? If it's divisible by this I, and we are definitely going to use the modulo. If it's divisible, definitely we are going to print that particular number to be added. So let's see how we can make that possible. So if that particular number that you're going to give, once it is divided by 2, once there's a modulo attached to it, that is going to be I. If it's equals 0, then what are we going to do? We want to print that particular I, which means that this I is going to increase as it is going through the loop. By the time we now set the condition of I, it means that this particular I is starting from 2. It's starting from 2. But as you keep remember when we said, what did we say something about a condition of what? A condition variable. By the time it sets a condition variable, and this particular I now becomes what? Now gets to a particular point, which is going to be what? The number, what that particular condition is false, is going to stop that particular while loop. So let me just give a practical example. Let's see if it's going to print. I remember that I is each of the members as it is going around each of the loop, and it's adding. When we said the value, the condition variable right now, it's going to be adding one after the other until this particular condition, while I is less than number is becomes false. Immediately it becomes false. That's when this particular loop would definitely stop. So let's set a conditional variable, and by the time we set a conditional variable, we are going to set it in the while loop, not in the if block. We did that last night. So we're going to keep backspace and now say I plus equals to what? 1. That means as each of the loop is going through, I is increasing by what? I is increasing by what? By 1. So by the time we do this and we decide to run this, so let's input a number. Let's say we want to input a number like, let's say 48. And by the time we press enter, you can see what happens here. So the factors of 48 here, we have 2, 3, 4, 6, 8, 12, 16, and 24. I don't know if you understand what just happened. So at what condition did this particular while loop become false? Any answer? Anybody that wants to try? At what condition did the while loop become false?
Sorry, Mr. I didn't get your question.
At what condition did the while loop that we did while I less than number, at what condition did it become false? I want you to just not just cram the whole concept of factors. I want you to understand what we are actually doing. At what condition did it become 4 that it had to stop at 24? Fantastic. Emedion said when I now became greater or equals to the number. When I becomes actually I think it's when I becomes greater, because we do not add this particular because if you had added equals sign here, this particular number, the number could have also been involved in this scenario of 48 could have also been involved. So see what happened here, guys. Please pay attention. Let me try and put it in. Let me put it in a way that you able to understand, because it's very important. While loop could be really, really annoying at some point, you may not really get what you are doing. So let me try to save it up. So look at what happened here. We started this course now, and this is what we did. Now we set a number equals to integer, and we said enter a number. While the beginning part of I that we are using is equals to 2. Now, what happened on line 3 said, while I is less than the number, that means any number that is going to come in by the user, while I is less than that number, this while loop will run. That means as far as this number is greater than I, it means that this particular while loop is going to run. Now, what happened is that now we are setting a condition to make it a factor. If the number that the person is going to do is a modulo division, that means anytime this illustration is coming up one after the other, it means that as it is coming and it's dividing with this I, it doesn't have any remainder. The remainder is 0. It means that is a factor of it. As each iteration is coming up, when I say iteration, each looping, each rotation, each cycle is coming up. As each cycle is coming up, it's adding +1 to this particular cycle, and which is what we did on line 6. So it's going to print the value. So this is what happened. So the first cycle came, it became 2. The next, and this particular 2, once we say that once this 2 comes in contact with 2, it divides, a modulo division comes in and it divides it, and it becomes what? It becomes what they call it. This particular number is going to divide it, and it's going to be 0. Once it gets to the same thing as 3, 3 is now added, this thing, particular I adds another 1 to it. It keeps on increasing. That means 3 can divide 48, and after that it add another 1. That means 4 can divide can go through 48, and there is no remainder. That is 0. It keeps on going like that until that part. Once it gets to 48, now this particular 48 is not greater than this particular, is now what they call it, I is now greater than this, but it's now either greater than this particular number. That's why it has stopped at 24. But if we decide to put equals to, it's going to involve this 48 as well. I'm trying to make you understand this whole concept. I don't know if you get it at all. Please, do you understand? I think I made your own guess right. But do you understand what I'm just doing right now? Because I want you to get it. Please, if you understand, raise up your hand. Just find a way and put up your hand somewhere that you understand. Suppose say you understand. You understand. Any other person, please let me know. Hey. Okay, because won't say you understand. Then you're one of the other persons. Huh? Say now you're not raising up your hand. Mr. Sunday, you're not raising up your hand. Okay. Mr. Sunday, are you here? Okay, you get it right.
I'm trying to do so. I think network.
Okay, all right. What about Dr. Kwemi? Dr. Kwemi, are you here? Do you understand what is going on?
Yes, I'm still trying to decide whether I understand or not.
Okay, all right. Okay. Because you're in the last
But
class, you're supposed to
I
have
think I
less.
understand.
Okay, Mr. Alpha, do you get the whole concept?
You people are saying you are trying to understand. I will understand.
Okay, it's okay. We are actually getting the one after the other. I think it's just mainly that after each illustration, after the particular thing, we are adding to it. As you keep on adding to it, as you keep on adding to it, that number that is adding plus one to it is divisible by the number that you have already put, that is 48. It means that particular number, that means you should print the value of I. For example, now it has printed 3, it has printed 4, it has printed 6, printed 8, printed 12, printed 16, printed 24. It's supposed to have printed 48, but because of the condition that we kept here, it did not print 48 as well. So I think that's the whole thing, the idea of the factors of a particular number. So let's get to this is a very popular question in programming. Find find if a given number is a prime number. Find if a given number is a prime number. How do we do that? We can decide to say, first of all, this is when we are going to use uh, true and false in a particular value. We are going to look at it like a Boolean kind of true or false immediately we start. So first of all, we're going to ask the user to give us a number. We're going to ask the user to give us a number, and that number is definitely going to be at least there, and it's definitely going to
Sorry to interrupt, please.
be okay.
Sorry to interrupt. Before we move forward, let me ask a quick question.
Okay, sir.
Okay. That line says this previous
Yes,
code.
sir.
Yes, this I plus equals to 1. What is the
Yes,
function?
sir.
I'm
It is
just trying to, I
now.
understand that, I
Remember,
understand that, sorry, I understand that these
yes,
numbers are like the output 2, 3, 4, 6, their numbers are divisible by 48 without remainder.
mm-hmm.
I understand that. And the I plus 1, I am kind of, I'm not sure what it's supposed to do,
It
but I
does.
have an idea. So I wanted to be clear. That's why I pulled us back. Sorry about that. So the
Okay.
I was equals to 1. What is it supposed to do?
Without
Let me
this
just.
without this I plus without this I plus equals to one, there will be no
Yeah.
there will be no factors at all. Because as remember that we started as two, I equals to two, and this particular I equals it means that anytime without remember when I said that looping is going one after the other. As it's going a particular cycle, it means that as a cycle is going on, I value is going to increase towards plus one. That means if originally it was two, the next cycle is going to be three. The next cycle is going to be four. And this cycle that is going to be is also rotating and adding values plus one. Is that particular thing that is doing, is it divisible if being given to the number that you have imputed, once you've given to that number, is it divisible? Does it give us a value that is zero? Once you divide them, does it have any remainder? If there are no remainders, modulos, remember, you know the concept of modulo. Modulo means that you can divide that thing without any remainder. So if there are no remainders, it's going to be zero. So is in each of the looping, does that particular number that is being looped, that is added plus one, once you give a modulo division, does it have any remainder? If it does not, if it has a remainder, it means it is not supposed to print. If it does not have any remainder, it means it's supposed to print. If it has a remainder, it's not a factor. But if it does not have if it does not have a remainder, definitely it is a factor. Don't know if you get it now,
Okay.
Mr.
So if I
Do
get
you
you
get it?
clearly now, that plus one is, without that plus one, maybe that code will have stopped at just 2. But because of that plus one,
Yes,
it will jump
fantastic.
to the next
Fantastic.
factor that
Yes,
can go through the day without a
it's
reminder. Is that what it
yes,
is?
thank you. Exactly, sir.
All right. All right. Thank you.
Right, sir. So now let's go to how we can print a given number to be a prime. To see if a given number is a prime number. So let's see how we can do that. So we're definitely asking users to put a number. Please compute a number. Okay, and decide to input a number. And what are we going to do? And I'm going to use that number. Let me stop this. Let me stop this particular code. Let me see editor. Let's not show lines right now. We are debugging. So by the time we do this, so the next thing we want to do is now please pay attention. This is when we are now going to use the Boolean value. I said, let's assume the number is prime. That means any number that we're going to get from the user is prime. Let's assume that the number that we're getting from the user beginning is prime. Don't worry about it. As we get along, we're going to change that condition. If it's not prime, this is what you should do. So in the beginning, is prime. Is under, you can define a variable name and say is prime so that we can make it descriptive enough, equals to what? True. Remember, this is a Boolean. So we are now setting that particular number. Say, okay, let's start it as say is prime equals to what? True. By the time we do that, I said, okay, remember when we did for the previous one? So we are going to define another variable. Let's continue using I equals to 2. And I said, while I is less than that number, while I is definitely less than the number, almost the same concept we want to use here. While n is less than that number, now is that number divisible by I? That's when we are going to go there now. Is that particular number that is going to be given by the user, is it going to be divisible by I? If it is divisible by I, that means it is not prime. That means that number is definitely, that is underscore prime will change to what? False. So if number, that's modulo, we always use modulo to find the remainder of that I that we're going to get now is equals to 0. That means it does not have any remainder. It means that it is not a prime number. That means it is definitely not a prime number. So what are we going to do? We are going to set the Boolean value which we started before as is underscore prime equals to true. We are going to change it from is underscore prime equals to false, so that we can actually get what we want to do with this particular prime number. Please pay attention. So is underscore prime equals to what? It changes to what? False. To use a capital L. So by the time it changes to false, it means that we want to do what? We are now going to set a condition. Set the condition variable is going to definitely is not going to be in the if block, it's going to be in the while loop. And I said I, this is when it's going to be increasing. As it is increasing, I equals to I plus what? I plus what? 1. So by the time you do this, you now said, okay, now this particular condition has now becomes false. If this is actually what? False. Now, what happens to if it is true? If it is what? True. What are we going to do? What if this particular thing is prime? What are we going to do? Now, this one we now go to the next one. It's still going to be in this particular, the same line as the what? The while loop. Because this one is already creating itself. This particular one, the one you are seeing here, has finished its work in this particular. So we're now going to say, okay, once we are through with this condition as being false, what are we going to do in the next stage of our coding? So please pay attention. So we're now leaving this particular loop, and I said, okay, if what you are doing is prime, what are we going to now do? So if is prime, if underscore prime is what equals true. Equals true. What are we going to do? Sorry, so if it is true, what are we going to say? We are going to definitely tell the person that that number in which we are inputting is a what? A prime number. So print, we can use the F string, but I think everyone likes using the formatted F string, but let me use the formatted string, the dot format kind of string here. So you can use F string, it will still work for you. But I've gotten used to when I started coding in Python 2, but nevertheless, so we use a curly bracket and define the variable which we want to use as the first one, which is 0, which we want to just define it as 0. You can decide to keep it empty at some point, but let's just is what is prime. So what are we doing? Dot format. What are we putting? We're referencing the variable, which is what? Number. So is what is prime. What then? If it's this condition, that means print it as what? This particular number in which you are putting is prime. But what if it is not? Then we now say else. This is when the condition comes in for else and said, okay, if it's not prime, as we did for on this particular, if this is going to be what false, this is what we should do. So if it is else, what are we going to do? We're still going to print. We're still going to print. And what are we doing? We can decide to just copy. Wait, let me just copy this. No time to waste time. We'll just Control C. Let's click here. And we just change is not what is not prime. So by the time we run this, and let's see how we're going to make this work. So let's see. Don't worry. Once we run it, we'll find a way to explain it to you guys and let you guys understand. So by the time we run this, asking you please input a number. So let's input a number like say 29. Once we enter 29, you can see 29 is prime. Let's enter. We can decide to run it again and try another number. Someone should give me a number.
21.
21. So let's try 21. So 21 is not prime. We can see it here. So this is a practical example of how to find if a particular number is what? Prime. This is what happened. Let me go to tools and show the line number. So I don't know if you want me to start it. Okay, Dr. Fayemizan is up already.
Yes. Can I go on?
Yes, please go on.
Okay. You have to permit me. I'm going to ask some very simple questions, but I need to ask.
No. It's, everybody's learning. We are also learning.
Yes.
If I can
Let me
go
see your screen.
find a
I wasn't really paying
always
much
find a way
attention.
to make it work.
So if I was paying much attention yesterday, I won't need to ask the questions today. But let me ask them what to say. Line 5.
Okay.
Yes. This symbol that looks like 0. Is it 0? It's not 0 now.
Which one? The percentage sign?
No. The last before the column is not 0,
Is zero.
right?
Is zero.
Okay. Then this line 10. Why are we saying print 0 is prime? Like, what is the function of that 0?
That 0 is referencing a value that we have, a variable we had as number. You can decide to use F string. Yeah.
Okay, you
It's
can
just
decide to
another
use
format.
anything.
You can decide to use F string instead of this particular this thing. you can decide to use. Is the format is a way of representing a statement using a string kind of formation. So if this
Rather than
zero,
using this, rather than using this zero, why can't we just say print like number? I know by this zero you are referring to the user input, right?
yes,
Whatever
but
user will
what you
input.
yes, this number is trying to like this is what we use for. We are trying to create. See what we are doing here. You can see is not prime something at the output. So we are
No, I
looking for a
understand
way
that.
to.
I understand that. I understand that quite all
Okay,
right.
what do you want me to? What do you want to do?
Yeah, this zero, I know you are
Yes,
trying to refer to it as what the user will impute. Whatever number the user imputes, you are
yes,
trying to use that zero
yes.
to represent it. Is it that we must use zero or we can use anything to represent it?
You can use anything to represent it as well. But mostly,
I
I believe that mostly maybe when I was programming, I always use zero. The next one will be one. The next one will be two. And I've never really said for once try it out. But let's try it out and see.
okay.
Let's try it out and see if it's going to be true. But if it's not, we'll find a way to let's say okay, let's see if it's going to be true. But so let's see. Let's see 9 again. It's an error. It's not going to work. Sorry. So it's
Okay.
actually what it's always zero. It starts from zero as well. Remember now, it's always zero,
Okay, we should
zero,
just use
one,
zero.
two, three. Yes, yes, for format string. Sorry about that. It's supposed to be zero, one, two, three. Start with zero, one, two. I remember now, but some points. That's why the F string came out and now said, okay, instead of using all this long protocol, I always love the F string, but at the end of seeing myself using the
Oh, okay.
definitely.
Wait, it's all right. It's all right. I'll get through it. Question number 2. This dot format number, what is it supposed to do?
Okay, the dot format is trying to concatenate the strings and the number itself, like it's like bringing two data types into one. For example, the number that is coming here is definitely an integer. So by the time it brings it out here, it's going to do what? It's going to concatenate it and just there's no need of adding plus and all those kind of stuff here. So it's more of like let me see something. Let me show you something. Um, instead of using these guys, please sorry about that. So let's instead of using uh this particular format, you can use the F string
Okay.
and reference.
This is the
You can
one
use
I'm
the F
familiar
string
with.
and reference it. This is the one you're familiar. Okay, what should we do now? Okay,
Yes.
how should we take
You open the curly bracket.
it? Yes.
Yes. And put number.
Okay.
Then you
Then
close it. Then you write
yes.
it's prime or it's not prime, and then you. This
Okay.
is the one I'm familiar with actually.
Okay. This
Yeah.
this is the one I'm also familiar with, but I always want to always make it uh go more complex when it comes to format. Dot format. Dot format is something I started learning from the beginning. So I still feel it's more
Yes.
of a like
This is the one. This
so
is
this
the
one
one
is
I'm still
actually
for now.
this is the one you should use actually, but I sometimes always try using different methods. I can maybe tomorrow I can decide to use
At
F
least this
string
one I
and
understand. The other one I will have
okay,
had to cram it. So I had to be
okay,
clear about that. Sorry for taking the class back.
all right. Uh,
Yeah.
any other questions?
Yes, so I have a question.
Oh, Mr. Ko?
Yes.
Okay, all right. You can ask your question.
Okay, I want to ask the line 7, or rather the condition used in this second example, is it
Mm-hmm.
different from the condition used in the first example, or is it just another way of expressing it?
Which other example? The first example I did here. The
Yes,
very
the
first one
line
you did for
7 on this
factors.
second example, I plus I plus 1. Yes.
Yes, it's the same thing. It's the same thing as this other. Like it's the same thing as I told you I can use different methods. So it's the same thing as
Okay.
what we did on line 6 here over here for the factors here. Please, any other questions, guys? Mr. Sunday, okay. I think we'll have to answer a whole lot of questions. I can find a way out.
Yeah, please. Can you please go back to the code?
Okay.
That condition, if number modulo I equals 0. So
Okay.
I'm still trying to understand the
yes,
this code.
okay.
What is the major difference? Like that, what makes it to be a prime number? Because class, I just
an
where be
odd
the
number,
odd number, because that's what I've been thinking about. What really make it to be prime?
Now, what is a prime number? First of all, that's the first thing that.
A prime number of just two factors. I can only divide the 7 and 1.
7 and 1. Okay. First of all, look at this. Let's look at this again. Let's look at this condition again. So if number is equals to integer, that is the integer is going to impute an integer. But now what happens here? If that particular number is what? Please pay attention. It's very. So if that particular number that we're going to give is what? By the time you pass it through the value of I, which is original, the first one is what? The first one is 2. So if for example, you decide to pass, what they call it, I don't even know how to get it for you to understand this concept here. So the number here, which is anything that we put here, could be 29, and I said is modulo of what? Or let's say 2. For example, we decide to say, what they call it. The first one we did was 28. So if that particular 2 is what is it's given a modular division that is going to be what? 2, and it's going to, which is 2, which is going to give us 0. Definitely 28 and 2 definitely give us what? There will be no remainder. Now, if it is there is no remainder, it's going to say, remember that we started with the what? With a true condition here for Boolean. So by the time you set it already the beginning and set it as what? As true. That means anything that we have that we want us to run in this particular code will definitely what? Come out as true. But the other one that is definitely, that has a division and there is no remainder, is going to come out as false. I don't know if I don't know if you could get me the way I'm seeing this. I may not really Mr. Sunday, I don't know how I'm going to explain it to you right now. Is there anybody that wants to help me out?
Like really, I understand what you are saying, but the division by 2, I think when you divide by 2, it's going to be false, really. But I'm just thinking that it could have as well be odd number, like
it could have as well be. Yes, that's why this condition is coming here. That's why we are starting with is underscore prime equals to true. That's the condition. Because when we're doing for odd, we did exactly, when we're doing for this thing, even and odd, we did not bring in these particular conditions of beginning as Boolean as is underscore prime equals to true.
Okay.
That's the only way I can actually find a way to work, except I'll go back and I'll break it down in a very much simpler way for you to get it. Though there may be other ways of getting a prime number, but this is the simplest one I've seen so far without looking at different loads and loads of code, like different conditions.
Okay. Thank you.
All right. Any other questions?
A quick one before we continue. Continue. This line 3, I equals to 2. That 2 is an assumed number, right? It could as well be any number we like. It could be 3, it could be 4, it could be any number we want, right?
Yes, it could be, but right now we're using 2 because we want to use to reference a particular. We want to use it as a starting number for for a particular, the starting number for what a particular prime this we want to use. So it's more of like a starting number, and also we're using it as a division, beginning of the division of a particular prime number we want to include, any number we want to include. But in this particular one, it could have been any one. In this particular, what do they call it, for factors of 2, but we still started as 2 as well. So that is more of like a way of just getting things done at some point for you to understand at this level.
All right. Thank you.
I'm just imagining those ones that miss the class, how they will get it. Because I already sent a message across, because even people that are here, I've not heard some people's voices here. Mr. Manuel, can you, okay, is it, Mr. Manuel, are you here with us? Can you see what is going on? Is Mr. Manuel with us? Okay. Mr. Are you with us? Okay.
Yeah.
Okay, she says she's with us. So, Ms. Udrak, do you understand what is going on?
The questions persons are asking, they are helping us to follow. So I think from what they are asking, I can follow easily. So no need to ask the questions again.
Okay. Emeja, are you with us?
My eyes is a bit noisy. That's why.
Okay, Mr. Manuel, no problem. Emeja, I did not hear you. Okay. So now let's look at the concept of, I want to include the concept of infinite loop. I think from there we can actually say we want to call it a night. So let's look at the concept of infinite loop. What if we do not set a proper conditional variable? What if we decide to, at the end, we do not put in this I equals to I plus 1? What if something happens to us and we decide to forget it and see what will happen? So let's do a mistake and create an infinite kind of condition. Let's see what we'll have. Let's see. So let's just define something. Maybe we just wanted to create a particular value. And I say I equals to, let's say, definitely we always start with, we can decide to start with 1 or 2. Decide to start with 1. And I said, okay, while I is less than what? Is less than 10. Guys, please pay attention. If I is less than 10, definitely print what? Print I. Very good. So now already I is definitely less than 10 right from the beginning. Now, what do you now do? You now decide to say, okay, as I'm doing this, instead of me to say, okay, plus, as we normally do. Remember, we used to do plus here, and it will work for us, and it makes everything make a whole lot of sense. So instead of saying I plus, we now decide to use minus equals to 1. And decide to run this, guys. What do you understand by this particular code here? It means that as far as I is less than 10, this code should keep on running. Now, you are putting I to be minus any value that the starting value of I here is 1. It means that after every cycle, after every looping, it's going to be minus 1. So 1 now becomes minus 1. 1 minus 1, 0. It is still less than 10. I is still less than 10. It goes to another loop. It continues minus 1, because 0 minus 1 will give us minus 1. It continues again. It is still less than 10. It continues until it gets to infinity. All those negative signs are still less than 10. I don't know if you get the concept of the infinite loop here. So let's run this and see what we'll have. You can see what is going. So it's still I can't even stop it here. So until I have to press it again and again, you can see it still keep on going and going. You can see it's not even clicking again. So it will keep on moving until you decide to say, okay, let me stop at some point. So this is an infinite loop because why is it an infinite loop? Because you can see it's still moving. Okay. Why is it an infinite loop? Because this condition is still met. Because this condition has still been what? Met. Because it is I is still definitely less than 10. As it is minus here, it is still less than 10. So the condition will still keep on moving until infinity. In fact, is there any end of infinity? Nothing. So the only thing we could have stopped here would have just to change this to what? Plus. And by the time we run this, something is going to stop somewhere. You can see that's changed. Once it got to 9 and it got to 10. So that means 10 is now, I now becomes 10, which is almost the same thing as what this thing, and definitely stops here at less than 10. So if we continue like that, maybe we can decide to add, instead of 1, and decide to use 2, you can see that your value will definitely be in forms of 1, 3, 5, 7, 9. So these are the things that we're looking at. So that's a practical example of an infinite kind of what loop. So in the next class, we'll look at the concept of for loops. It is very important that at least you understand the whole idea behind while loop. Okay, Mr. Luko, your hand is up. Sorry, I did not see that on time.
Okay, I want to ask, please, can you go back to the code?
Okay.
I want to ask, what if there's no conditional statement in the code? Because there's somewhere I read that if there's no conditional code, it will keep running.
Yes, it's also okay. Let's see. Let's run it and see the magic. So you can see this particular one. It shows only 1, 1, 1 because it's going to go through only one. It keeps on moving 1, 1, 1. It will show 1, 1, 1, 1, 1, 1, 1. Because the first this thing here was actually what 1, and there's no way of you saying you're adding anything to it. So it keeps on moving until it's infinity. It is not going to stop until you set a conditional variable. So it's going to say only 1 because you have not added anything. It keeps on as it comes back after every cycle. It comes back. Okay, I'm still seeing the same thing. I continue. Why? Because it is true. Because 1 is less than 10. It keeps on going. It keeps on going. It keeps on going. If you change this one to even 9, sorry, you change this one to 9 and keep on and run it like that to show 9, 9, 9, 9 until you set a condition that makes this particular while loop to be what false. Immediately it becomes false, it stops the loop.
Okay, thank you.
Any other questions? Okay, let's go back to, let's just give a hello sir, just logging in now. Hey Mr. Fuso, you're in trouble. There are lots of things that have happened tonight, so please let's go back and maybe give a recap. Or is there anybody that wants to give a recap of what we have done? Or just maybe you could we'll just go through telling us what to do. So let's see. Let me just make it. Let's just give a recap of what we did just in 2 seconds. Let me try to set the tools to the way that we can see the lines of code. It's showing lines of code already. So we started tonight with factors. We say we wanted to get the factors of numbers, and we defined the number equals. We wanted user to give us a number, and by the time we gave it, it's going to be an integer. We passed it to become an integer, and the input give us this. And we defined a variable. We started with a definition of a variable, and we defined that variable to be true. So while that I, which is already 2, the beginning, is less than the number, it means that any number that comes in here, as it keeps on looping, as far as it is less than this particular number, the while loop will keep on moving. So if that number is, it gives a modulo division and there's no remainder of the value of I, which keeps on adding after every looping, it means that that particular number is definitely the factor which we want to print. So by the time we did that, we saw that this is what happened. We gave different factors of, we used 48. We are not including 48 because we did not add less than or equals to here. So by the time we do this, it gives us 2, 3, 4, because those are the numbers that once we go through each of the loop and we give it a modulo division, the remainder is 0. It means that that is a factor. So we kept on doing like that until we understood the whole concept. There were a lot of questions asked, which we definitely answered. The next concept was to know if a number is prime. And how do we differentiate the odd and the prime factor? The odd and the prime one is using a particular Boolean statement. When we started the whole concept, we started with a number from the user. We want the user to put in the numbers. Once we did that, we said, okay, we're starting it from the very beginning and said is underscore prime equals to true, setting it as what true right from the very beginning. This particular concept is what makes it very prime, differentiate it from odd and even numbers as well. Don't worry, maybe you get to read about it. You see that this is a way of trying to explain it in a kind of prime way. So we define I to be equals to same as the same thing we did here. And I said if that while that I is less than the number that's going to be, it means that if number modulo that I, the value of I equals to 0, that means if it's given a remainder, if there is no remainder, definitely we are going to change the condition of that prime, which was already true, to false because it has no remainder. By the time we do that, this is a conditional variable, and I said, okay, after every iteration, just add 1 to I, and let's see if that particular number is definitely a prime number. So we now went, after the conditions were met here, we now said, okay, now that you have done all this, how can we now bring these values out and bring them to the user? And I said, okay, if is underscore prime is definitely equals true, this is what you should do. We use a dot format string, which we saw something new tonight, which I've never tried it for once. I've always used the F string, but I wanted to try this out again and see. So someone asked if we can add 1 here, 2 here, and any number. I said yes, and at the point we found out that it was definitely not true. So we always use start with 0. If you are using 1, if you are just using just one variable, anyone you start with 0. If there are 2, you start with 0 and 1, like that until according to the numbers of the variables we want to reference. So that's why we now switch to F string here. We made it very simple for us, and that was how we created our prime numbers. Once we ran this code, it worked for us. We checked the different numbers. Once we check, it said 28 is prime. 28 is not prime. We checked 29, said it's prime, and all those kind of stuff. We now went to the infinite loop, and we now said that if we do not set a condition, keep on going one after the other until infinity, and beyond. Do not stop until we set a condition that is valid to this particular while loop. We saw a lot of examples. We set it as -1, it went backwards, and this condition was still possible. So it kept on looping in an infinite kind of loop. So at this particular point, I would like to say good night to everyone. The recording will be available. Please go through it. This is a very critical stage in programming. A lot of people get mixed up here, and a lot of people give up at this particular concept of while loop. Please go back, look at it again and again and again. Please. Thank you very much for joining in tonight. And if you have any questions, if you try going through the videos and you don't understand, please always feel free to send a message, and I will definitely find a way out for us. Thank you very much. Bye for now.
Good evening.
Yes, good evening, sir.
Please, can you post